As we near the end of another year, it's always a good time to gain perspective on just how far we've come with space station research, as well as where we're headed. Lori Meggs at the Payload Operations Center at NASA's Marshall Space Flight Center is going to give us a little bit more information on that. Lori?
It's been an exciting and record-breaking year for research on the International Space Station. I recently spoke with NASA's chief scientist, Ellen Stofan, to get her take on just how valuable this orbiting laboratory is.
It really runs the gamut. We just took up a new Earth science instrument that's going to be measuring ocean winds, really critical to be measuring it at different times of the day so that we can get a much better handle on how the ocean interacts with the atmosphere. We also announced new findings from the alpha magnetic spectrometer on board the International Space Station that's doing work in cosmology. What are the fundamental particles that make up the universe? How do they work? Is there dark matter? Huge, basic questions, and we're addressing them using the International Space Station. In addition, and you know, it gets almost, you're thinking, how can we be doing so much? We had experiments that included a 3D printer to start testing. Can we eventually get to a point where we can produce parts for the International Space Station on the International Space Station rather than bringing them for Earth? We took up rodents for the first time since the shuttle days, and we're going to be using these rodents as model systems to better understand the effects of microgravity on the human system, and using those mice potentially for drug development. Things that happen to the human body in space, like bone density loss and muscle wasting, are things that happen to us as we age. So can we use the fact that these processes occur very rapidly in space to develop new treatments that benefit us right here on Earth? So direct benefits to the world of science, direct benefits to human health, that's the kind of research we do every day up on the International Space Station.
As the chief scientist, though, I'm sure you want to see more. There's more that can be done. What do you tell folks about that?
You know, that's why this extension to 2024 was so important to me, because as a researcher, you really want to be able to say, can I come up with a theory, come up with an experiment, send it up to the ISS, see what my results are, and tweak my experiment, go further, go to the next step. And that's what that 10-year extension of the ISS has given us. And so the rodent research I was talking about, we're just beginning. We're going to have rodents, model system, fruit fly experiments going up on the ISS that are really going to help us start addressing questions on how do we send humans on that long journey to Mars, that 8-month journey to Mars, 8 months back, time on the Martian surface. That's a lot of time out of the Earth's protective environment that protects us from space radiation. So we have a lot of research to do on the International Space Station over the next 10 years to really get ready for that journey to Mars, and we're excited about it.
And the space station has also given researchers who may not have ever gotten anything in microgravity, they've given them an opportunity. It's easier now to get on the space station, right?
It is easier. We're really working at NASA to try to make the ISS a researcher-friendly environment, and through our efforts as well as CASIS, which is the organization that runs our national laboratory on the space station, we're trying to get new partners, not just our traditional research crowd, but can we get pharmaceutical companies? Can we get companies that do materials research? Can they start seeing the benefits of doing microgravity research? So we really want to exploit not just the scientific potential of the International Space Station, but its potential commercial uses.
We're getting ready to have a crew member on the space station for a year, and we'll learn things from that will help us in that future deep space exploration, right?
The one-year mission is something that we've really been looking forward to in the Human Research Program, because there are a lot of things that happened, again, to the human body in space, from, again, the muscle wasting, bone density loss, the rise in intracranial pressure that affects vision, changes in the immune system. Our crews mostly go out for 6 months. So, okay, what happens after 6 months? Do those effects plateau? Do they lessen? Do they get worse? Those are things we really want to know. And so by having the 2 astronauts up there for a year, Russian astronaut, US astronaut, it's a great opportunity to really push that envelope and what we understand about the effects of microgravity, and again, critical for this much longer trip to Mars. The other exciting aspect, of course, of the one-year mission is that Scott Kelly, who's going up for a year, happens to have a twin brother, Mark Kelly, former astronaut, who's here on the ground. And so not only are we going to be doing the one-year studies of the long duration effects, we're also doing a number of twin studies to say, okay, we've got one in space and one on the ground, same genetics, what can we learn from that? Really exciting.
What do you tell folks who say, the space station, that doesn't mean anything to me?
You know, I really try to focus on this fact that when we're working off the Earth, we're working for the Earth. From the RapidSCAT instrument that we just put up to help measure ocean winds, which is going to be able to allow us to do better weather forecasting, better understanding of the climate, that's something that affects us directly right here on Earth. From things like, again, bone density loss. Okay, that's what happens to us as we age. Osteoporosis. We're looking into developing new treatments based on what we're doing on the space station. So while we're not right here on Earth, everything we do is to benefit the Earth. And those technologies that we develop are being done right here on Earth. We send them up to space and test them. And there's huge numbers of spin-offs that come from that. The benefits of the ISS, to me, are just endless.
And taking a live look into the Payload Operations Integration Center, the stockings are hung on their signs so gently with care, hoping St. Nick will soon be here. So we want to wish everyone happy holidays, Merry Christmas, and a Happy New Year from the Payload Operations Integration Center. And please join us next week, next Wednesday. We'll have a special 30-minute program featuring all of the research on Space Station for 2014.